Hi everybody, and welcome to parallel and perpendicular lines. So we're going to talk about what parallel and perpendicular lines look like in terms of a visual representation, which would be a graph. And we're also going to be talking about parallel and perpendicular lines and how their slopes relate to each other. Okay, so for example, for parallel lines, we're talking about two lines that are never intersecting, meaning to say they never cross. A parallel line has the same slope, meaning to say the same steepness. So if we take a look at the picture over here, we see that the two green lines are never crossing, so they are parallel. And if you take a look, the steepness is actually the same for both lines. It's just shifted. Okay, so that's why the slopes have to be the same. Okay, something to recognize is that all vertical lines are parallel and all horizontal lines are parallel to each other as well. So let's do a couple of examples. Okay, the first is going to be find the equation of the vertical line that goes through the point 3, 4. So first things first, a vertical line always has the same equation, which is going to be x equals a number. Therefore, when we take a look at the point 3, when we take a look at the point 3, 4, then that means to say that we need to make sure that it goes through x value 3, which means that the equation for this line is going to be x is equal to 3, and that is going to ensure that it goes through 0.34, and that would be your answer. Okay. Now, the second example is find the equation of a line parallel to the line y equals 2. So, and it passes through 4, 6. So we want it to be parallel, meaning to say these slopes are the same. Okay, well, what's the slope of the line y is equal to 2? Well, y is equal to 2, that is a horizontal line. And it's going to have a slope equal to 0, which means we need another horizontal line, which always has the equation of y is equal to some number. Okay? So, now that we have that, we're going to go ahead and we're going to take a look at the point that it's supposed to go through. The point that it's supposed to go through is x is equal to 4, y is equal to 6. And I need a y equals another number, which means I'm going to use y equals 6 as my other equation of the line that's parallel to y is equal to 2, because all horizontal lines are parallel to one another. Okay? Now, let's talk about perpendicular lines. Okay? So perpendicular lines are going to be two lines that intersect at a right angle. These are called perpendicular lines. So again, we're going to take a look at the picture here. This one right there. And if we take a look at the two green lines, they are intersecting at a perfect 90-degree angle. Okay, so the two non-vertical perpendicular lines have the slope that are opposite reciprocal of each other, and that is super important. Opposite reciprocal of each other. Meaning to say, if you multiply the slopes together, it's going to be equal to -1. All horizontal and vertical lines are perpendicular to each other. So if I know that my slope, and I want to find out the perpendicular slope, that's going to be opposite of 1 over what my original slope was. This is what we call opposite, okay, reciprocal. All right. Okay, so the next example doesn't really have to do anything with parallel and perpendicular lines, neither does example 4, but then we're going to come back to parallel and perpendicular lines for example 5. So for example 3, it says find the equation of a line with the slope of 0, meaning to say it's going to be a horizontal line that has the equation y equals a number. So again, we take a look at what the point is, and we look for the y value, which is -5, and that is going to be, okay, my equation. For example 4, we're going to have find an equation of the line with a undefined slope, meaning to say it's going to be a vertical line. And every vertical line is going to have the equation x equals a number. Therefore, we look at the ordered pair, which is -4, -8, and we're going to specifically look at the x coordinate, which is -4. So that's going to be our equation. Now, let's go back to parallel and perpendicular lines. So I am given an equation of a line, and notice that this is in standard form. So we are going to have to play around with it a little bit in order to get it into the equation that we need to get it to, which would be y-intercept, which is y equals mx plus b. Because keep in mind, we need to know what the slope is for both parallel and perpendicular lines. Okay, so we're given the equation of a line, we're given a point that the new line has to go through, and we want to know what if the lines are parallel? What would the new equation be? And then we're going to figure out, well, what if the lines are perpendicular? What would that equation be? So first things first, before we do anything else, I'm going to do a little side calculation here where we're going to go from standard. We're going to go to slope-intercept. Okay, so here we go. We have 9x plus 3y is equal to 8. So we want to get the y by itself. So I'm going to subtract 9x from both sides. That's going to cancel, and I have 3y is equal to -9x plus 8. The next thing that I'm going to do is I'm going to divide every single thing by 3. Okay, so that's going to cancel. I have y is equal to, well, -9 divided by 3 is -3x, and then 8 divided by 3 really doesn't simplify because that's as simple as it goes. It's just going to end up being a fraction. But that's okay. Because I really don't care about the y-intercept. I really just care about my m, which is -3. But if I wanted to graph this, we could have that the b is 3/8. I'm sorry, 8/3. 8/3. My apologies. But this right here is really important, the slope. So I know that the slope of the original line is 3. Okay, which means for parallel lines, for my two parallel lines, the slope has to be the same. So the slope of my perpendicular line also has to be, and I'm sorry, -3. Has to also be -3. And I am given a point that it has to go through, -1, -4. Which means I am going to use my slope-intercept form to plug in the things that I know to find what my b value is. So my y, that's my x coordinate, so my y is -4, my slope is -3, my x value is -1, and I'm trying to find what b is. So I have -4 is equal to a +3 plus b. I subtract 3 from both sides. So I have that b has to be -7. So my final equation here for parallel lines is going to be y is equal to my slope, negative 3, x, and then my b value, which is negative 7. And that is the equation of the line parallel to my original line of 9x plus 3y is equal to 8 that goes through the point negative 1, negative 4. So now let's talk about perpendicular. So again, the slope of the original line is negative 3. Okay, so my perpendicular slope is going to be opposite of negative 3. So the opposite of a negative is a positive. So positive 3. And the reciprocal of 3. So 1 over 3. Now let's do like a small little check here to see if my original slope times my perpendicular slope, does that give us negative 1? Well, my original slope's negative 3. My new slope is positive 1/3, okay, which gives us negative 3 over 3, which simplifies to negative 1. So that does work, and we just proved that it works. Okay, so just like we did for parallel lines, I have my perpendicular slope. I know that it has to go through the same point, negative 1, negative 4, where negative 1 is my x-coordinate and negative 4 is my y-coordinate, and now I'm just going to simply plug in the things that I know. So my y value is negative 4, and that's going to equal to my slope, which is 1/3, times my x value, which is negative 1, plus my b. So I have negative 4 is equal to negative 1/3 plus b. I'm going to add 1/3 to both sides. So I now have negative 4 plus 1/3 is equal to b. And I'm going to try and get that negative 1/4 to have the same denominator as 3. So that means I need to multiply 1 by 3. So I need to multiply 4 by 3. So I have negative 12 over 3 plus 1/3 is equal to b. So negative 11 over 3 is going to equal to my b value. So the equation of my perpendicular line that goes through the point negative 1, negative 4 is going to equal to my slope, which is 1/3, times my x value minus 11/3. Now, not quite as pretty as the first one, but we accomplished what we needed to accomplish. And we found the equation of the line that is perpendicular to the original that goes through a specific point. Okay, make sure you practice with these, because it does take a couple of times to really get the hang of finding parallel perpendicular lines. Okay, see you in the next video.